Unit SP14 Particle Model. Use a simple kinetic theory model to explain the different states of matter. So remember, that's solids, liquids and gases, in terms of the movement and arrangement of particles. So here's your three states of matter: solid, liquid and gas. Now your particle arrangement, you say that the solid is in nice neat rows, you get fixed volume, fixed shape, and the particles are very close together. As a result, the density will be very high. And how do the particles move? Well, by vibration only, because they're bonded together. The particles in a liquid are irregular, which means they're all over the place. They've still got a fixed volume, but they don't have a fixed shape. They'll fill the shape of the container. And the particles are close together as opposed to very close in the solids. How do they move? Well, the particles move slow and randomly. Particles in a gas are irregular, so it means they're all over the place. Not a fixed volume this time. A gas will fill the volume of the room. It's not a fixed shape either, and the particles are far apart. How do the particles move? Rapid and random. Or if you don't like the word rapid, just say fast and random. Recall and use the equation. Density equals mass divided by volume. So we use a wiggly P for density, M for mass, V for volume. Core practical. Investigate the densities of solids and liquids. So if you're going to investigate the density of a regular solid, for example a cube, well, always base your explanation on the calculation. So to get the density of whatever, you need to know the mass and the volume. Tell the examiner you'll use this equation. Tell the examiner that to get the mass, you'll use a mass top pan balance. And to get the volume, because it's a regular shape, you just do the height times by the width times by the depth. So just use a ruler. In order to get the density of an irregular solid, so that means like an odd shaped solid, again, tell the examiner you're going to use density equals mass over volume. Now you can get the mass once again just by using a mass top pan balance, so it doesn't matter that it's a funny shape, you can still put it on the top and you'll get the mass. However, this time to get the volume, what you'll need to do is take a measuring cylinder, so tell the examiner that, and fill it up with water to say halfway, and then plop the shape into the water and the water will rise. Now if we say the volume at first was volume 1 and the volume after you've put the object in is volume 2, then to get the volume of the irregular shaped solid, just do volume 2 take away volume 1, and that will also get you anything up to 6 marks. Now if you're going to get the density of a liquid, well, get a measuring cylinder, put it on top of the mass top pan balance, and then press the tare button to take it back to 0. When you put your liquid into the measuring cylinder, the mass top pan balance will just tell you how much mass of liquid there is. And the beauty of this is at the same time, the measuring cylinder will also tell you the volume. So you just get the mass and the volume by using the mass top pan balance using that technique. Explain the differences in density between the different states of matter in terms of the arrangements of the atoms or molecules. So specifically to do with the density, solids, the density is very high, liquid density is high, and gas density is low. So with the exception of water and ice, most solids are more dense than their liquid variant. And as they turn into a gas, so that's another physical change, generally the particles spread out even more. Describe that when substances melt, freeze, evaporate, boil, condense or sublimate, mass is conserved. So that just means the mass that goes in equals the mass that comes out. And that these physical changes differ from some chemical changes because the material recovers its original properties if the change is reversed. So sometimes if you have a chemical change, the properties will be totally different and you can't reverse it. But if you're just changing the state of matter, that's just a physical change. And if you reverse the change, you'll get the same properties back. So, if we start with solid, go into a liquid, go into a gas. A solid melts and turns into a liquid, and then it evaporates or boils and turns into a gas. If you cool the gas, it'll condense to form a liquid. Once you've got the liquid and you cool it, it'll freeze to a solid. When it's a solid, it doesn't have much energy. When it's a liquid, it's got more energy. And when it's a gas, it's got high energy. And sublimate is when you turn from a solid directly into a gas without going into the liquid state of matter. Explain how heating a system will change the energy stored within the system and raise its temperature or produce changes of state. So that's what I've just said there. The solid has got a low amount of energy, a liquid's got medium amount of energy, gas has got a high amount of energy. You know, you could be asked that in your exam, you get 1 mark for each of those things. Define the terms specific heat capacity and specific latent heat and explain the difference between them. So remember, it's only worth 1 mark. Well, specific heat capacity is the amount of energy needed to raise the temperature of 1 kilogram of a substance by 1 degree C. Specific latent heat for 1 mark in an exam, it's the amount of energy needed to change 1 kilogram of a substance from one state to another without changing its temperature. In other words, specific latent heat is what you use if there's a change of state. Specific heat capacity is what you use as you're heating one state and it's getting close to either the melting point or the boiling point. Use the equation. Change in thermal energy Q equals the mass times by specific heat capacity times by the change in temperature. Now, you'll have to rearrange that sometimes in order to find the specific heat capacity. So if you know how much energy you're putting into a liquid or a solid, and you know the mass of the liquid or solid and how much it's changed its temperature by, then you'll be able to work out what the specific heat capacity of the solid or the liquid is. Use the equation Q equals M times by L. So that's the amount of thermal energy needed for a change of state. And that's the mass times by the specific latent heat. Explain ways of reducing unwanted energy transfer through thermal insulation. In other words, wrap up something in foam or put a lid on it if you don't want to waste thermal energy from that thing. 1 mark for each of those things. Investigate the properties of water by determining the specific heat capacity of water and obtaining a temperature time graph for melting ice. So, here's how to determine the specific heat capacity of water. You'd need to fill a container with a known mass of water. And for another mark, measure the starting temperature of the water. For your 3rd mark, use a heater connected to a joule meter to heat the water. Measure the final temperature of the water. Measure the amount of heat energy used. And then calculate the specific heat capacity by using C equals Q divided by mass times by temperature change. The temperature change will be the final temperature. Take away the temperature at the start. I've got a nice little video all to do with that. Definitely recommend you watch it. Obtaining a temperature time graph for melting ice. Right, what you do is you tell the examiner that you would heat some crushed ice. You'd record the temperature and the time. So say heated for 10 minutes, record the temperature over the 10 minutes. And then use those results to plot your temperature time graph. Now what you should find is when it's ice, it'll start to heat up and heat up. Now, once it changes from ice, which is a solid, into water, which is a liquid, during the melting process, you should end up with a flat part of the graph. It's what we call a plateau. And that's because it's changing state. Now, you're still putting energy in because you're still heating it. So you say, well, where's that energy gone? Because the temperature's not going up. The energy is being used to break bonds, turning it from a solid into a liquid. Once it's fully turned into a liquid, then the temperature will continue to go up. Once it reaches a change of state again and changes from a liquid into a gas, once again you'll end up getting a flat part, which is your plateau. Now these plateaus, because there's no change in temperature, that's when you'd use this equation here. Q equals m times by L. You'll notice there's not a change of temperature involved when you're using the specific latent heat as it's changing state. As it's changing the temperature, on this section here and this section here, that's when you would use the equation for specific heat capacity, which does involve the change of temperature in the calculation. Again, if you're not sure about that, check out my video from the SP14 playlist. Explain the pressure of a gas in terms of its motion of its particles. You just need to say that the pressure of the gas is because of the motion of the particles. Pressure is caused by collision of particles. For 1 mark. Explain the effect of changing the temperature of a gas on the velocity of its particles and hence the pressure. Well, if you increase the temperature, that's going to increase the velocity of the particles and that's going to increase the pressure. And it does say for a fixed mass of gas at a constant volume. Describe the term absolute zero minus 273 degrees C in terms of the lack of movement of particles. So just make sure you know that the coldest temperature you can ever get is called absolute zero, and it's at minus 273 degrees C. And at that point, there's no movement of the particles, or it's very, very minimal. And therefore, if the velocity is zero of the particles, then there'll be no pressure either. Convert between Kelvin and Celsius scales. So if it does ask you to do this, to convert degrees Celsius into kelvins, take the degrees Celsius and add 273 to it. For example, if you've got 27 degrees C, that'll actually be 300 Kelvin. And to go from kelvins into degrees Cs, you take 273 away. So if you had 300 Kelvin, that's actually just 27 degrees C. So best of luck with your exams and good luck for your future. Work hard, be nice, and bye for now.